Question 16a. Define the term simple harmonic motion. Simple harmonic motion is a periodic to and fro motion about a mean position. So let's consider the motion of a spring that has a mass m attached to one of its ends. Let this be the equilibrium position where the spring is at rest. When you stretch or compress the spring about this mean position, it begins to oscillate. It begins to move to and fro about this position. And this kind of motion is called simple harmonic. So for a motion to be simple harmonic, you require three components. First, it must be periodic. That means it must repeat itself in regular intervals of time. Then it must be a to and fro motion. It must oscillate about a mean position. And for this to happen, you must need a restoring force. So the only reason the object oscillates about the mean position or go to and fro about the mean position is because of the presence of restoring force. And this restoring force is proportional to the displacement. Greater the displacement, more will be the restoring force. So in case of a spring, it is the spring force that tries to bring the spring back to its equilibrium position. Whereas in case of a pendulum, when you move the pendulum from its equilibrium position, it is the force due to gravity that acts as the restoring force, trying to bring it back to the mean position. So in conclusion, simple harmonic motion is to and fro motion of an object about a mean position, and it occurs whenever there is a restoring force proportional to displacement. Question 16b. The graph below shows the displacement of an object with time as it undergoes simple harmonic motion. What is the amplitude of this oscillation? So here in this question, we have been given the graph of displacement versus time of an object that is undergoing simple harmonic motion. And in the first part, we need to find what is the amplitude of this oscillation. Now, amplitude is the maximum displacement of the object from its mean position. So I need to find what is the maximum value it reaches along the y-axis or the displacement axis, which is 0.02 over here. And even the negative peak, if you notice, is also at 0.02, just the negative sign. So we can write the amplitude A to be equal to 0.02 meter. Then in part B, we need to find the angular frequency for this oscillatory motion. Angular frequency means we need to find what is omega. Now we can find omega as 2 pi over t. So if we can find the time period of oscillation, we can find the value of angular frequency. Time period of oscillation can be calculated by taking difference in time value of any two consecutive points. So let's say if I take the 0 over here, the point at x equals 0, and complete one oscillation and reach x equal to 0 at another point, when I take the time difference here, that will be the time period, which is the time it takes to complete one oscillation. And looking at the points over here, we get the time period t as 0.5 minus 0.1, which is 0.4 seconds. So you can take any two consecutive points, like I can take the first negative peak and the next negative peak, the consecutive negative peak. You will notice the time difference between them will also be the time period t, which is again 0.4. And you can do the same thing with the positive consecutive peak. So I take the first positive peak and go to the next positive peak and take the time difference. So it is 0.6 minus 0.2. That will again give me 0.4 seconds. So time period t for one oscillation is 0.4 seconds. We substitute that here. So we get omega equals 2 pi over 0.4, which is 15.7 radian per seconds. Next, in part C, we need to derive an expression for the velocity of the object. Now, before we find velocity, we need to first find the expression for position x. So let's assume position x to be equal to a cosine omega t plus phi. where A is the amplitude of oscillation which we found in part A. I assumed x to be a function of cosine because the graph over here is clearly a cosine curve. Omega is the angular frequency and phi is a phase constant because the cosine curve here generally should start with the maximum positive amplitude, but here we begin with the negative amplitude, so there is a phase difference or a phase shift here which we need to account for. That is why we have taken the value phi. So before we start to calculate the value of velocity v, we need to first find what is the phase shift or the phase constant phi. So let's consider the initial condition. Initial condition at time t equals 0. My x value is negative 0.02 meter. Because when time t is 0, position of x is negative 0.02. We are starting from here. So let's substitute this in the expression. We get negative 0.02 equals amplitude is positive 0.02 cosine omega. We are taking time t as 0 plus phi. Now cancel off this two term here. We are left with minus 1 equals cosine omega 0 will be 0. So we are left with only phi. So let's take cosine inverse to find phi. Phi will be cosine inverse negative 1. Cosine inverse negative 1 will be pi radian or 180 degree. So I get the value of phi to be equal to pi. Then we substitute this in x. We can write x to be equal to 0.02 in place of a. Cosine omega is 15.7 t plus pi. Once I have this value of x, now I can take derivative of x to find velocity as a function of time. So let's do that. I write v to be equal to derivative of x with respect to time. So we take derivative of 0.02 is a constant, keep it outside, d by dt, cosine 15.7 t plus pi. So 0.02 remains as it is. Derivative of cosine will be minus sine 15.7t plus pi. And then we take derivative of the argument of cosine of this term over here. So derivative of 15.7 times t is just 15.7. And pi is a constant without t, so derivative of pi will be 0. So now let's rewrite this. We will multiply 0.02 with 15.7. That will give me 0.314 negative sine 15.7t plus pi. So this is the expression for velocity that we get. And I can rewrite this expression by removing the negative sign. We know that sine 180 plus theta is negative sine theta. So negative sine 180 plus theta will be equal to sine theta. So I can substitute that here. That will give me the velocity v to be equal to, if I am going to remove the pi from here, which is 180, I have to replace the negative sign. I have to remove that negative as well. So we get v as 0.314 sine 15.7 t. This is the expression of velocity as a function of time.